Section 11.8 will be our last section about radicals, and in this section we're going to talk about adding and subtracting different expressions that have radicals in them. In this section, the basic method that we're going to use for every problem is that we want to add and subtract the coefficients on like radicals. This is a lot like adding and subtracting the coefficients on like terms when we were using variables. So when you're thinking about radicals, you want to be in that same mindset of combining like terms. That's going to serve you very well. So here's what I mean. If we want to simplify these expressions that I've put here, this first one says 4 square root of 7 plus 5 square root of 7. So the first thing we see is this is a square root of 7 and this is a square root of 7. This is what we mean by like radicals. The two pieces that are being added together, they have the same radical. It's just like they both had x or they both had x squared, etc. And when you see the like radicals, that means that to add them together, what you want to do is add the coefficients. So when I mean that we add the coefficients, we're literally just going to say, okay, we have 4 square roots of 5, and we're adding that to 7 square roots of 5. So we're going to add the 4 and the 5 and get 9. So that means that our answer to this problem is going to be 9, and then we're going to keep the same radical. So we're going to have 9 square roots of 7. So the radical that we had, that like radical, that is going to stay the same. So add the coefficients, leave the radical the same. Same thing works down here in example 2 with subtraction. We have our like radicals. This has a radical 2, this has a radical 2, and this has a radical 2. So that means that we are going to add the coefficients together. But remember, this is a plus 15, this is a minus 6, and then this right here, the plus radical 2, that's like having a plus 1 coefficient. So our coefficients are plus 15, minus 6, and then plus 1. So that's going to be 16 minus 6, or 10 on the coefficient side. So if we're going to write down a final answer, our final answer would be 10 for our coefficient, and then again, the radical stays the same, so we have 10 square roots of 2. So first example, 9 square roots of 7. Second example, 10 square roots of 2. Now, let's look down here at another example. In this one, you see we've got a square root of 6 and a square root of 6. However, we've also got this square root of 13, not a square root of 6. So what should we do? We can definitely add together the 5 and the negative 3 because we've got these with like radicals. So 5 and negative 3 is going to give us a 2. And we're going to have it with the radical 6. So 2 radical 6, and we got rid of that and that. However, we can't really do anything with this negative 2 radical 13 because we can't combine it with the radical 6's because they don't have the same radical. So what we're going to have to do is just write it by itself. Minus 2, because it was already negative, radical 13. So what we have to remember here is that terms with unlike radicals cannot be combined. So when I say unlike radicals, I mean ones like radical 6 and radical 13. They cannot be combined. So what we have to do is just leave it. So we just left the 2 radical 13 as it was. It cannot be combined. So what I mean here is that we just leave it. Just leaving it as is. And we are all set. So again, no like radical on the 13, can't combine it with the 2 radical 6's. So we combine the 2 radical 6's, 5 radical 6 minus 3 radical 6, you get 2 radical 6, and then you just leave the minus 2 radical 13 on the end. Now we're going to look at an example where things start to get a little crazy. As you can see in this fourth example, there are no like radicals. So, do you just give up? Is the problem over? You might like to say yes, I can understand why, because then it would be easy. However, sometimes, and we couldn't do this in the last problem, but sometimes you can do a little bit of creative mathematics and get like radicals, even if it doesn't look like they have like radicals. So what do I mean? What I mean is, maybe if we try to simplify this 2 radical 12, which is a little big, and this 6 radical 54, which is a little big, we might come out with some radical 6s or radical 3s. So we're just going to try to simplify each part of the expression to create some like radicals. So we'll try to do a little bit of simplifying. So first of all, we look at the 7 radical 3. And radical 3 is not a radical that can be simplified. We know that. It's very simple. So I'm just going to check this one off. I'm not going to do anything to it. 4 radical 6. 6 is also not a radical that can be simplified. We know that there are no perfect square factors that we can take out. However, 2 radical 12, I see some potential. So I'm just going to rewrite 7 radical 3 minus 4 radical 6 down here. And then this 2 radical 12, I think that you probably are thinking to yourself, oh, we can break that up. We can break that up into the square root of 4 times the square root of 3, which could give us some simplifying possibilities. And then that 6 and 54, I'm just going to write another little line down here. That might be a little bit harder, but if you think of perfect square factors of 54, you might remember that 54 is the same thing as the square root of 9 times the square root of 6. So I'm going to rewrite my line again. So I have 7 radical 3 minus 4 radical 6. And now this third part, we're going to write as 2, and then radical 4 is the same thing as 2. So I'll write 2 times 2 times radical 3. And then this line, this fourth part, we have 6. Radical 9 is just a 3, and then I have radical 6 on the end. So if I really rewrite with everything as simple as I can go, I'm going to have 7 radical 3 minus 4 radical 6 plus 4, so I combine the 2's, radical 3, plus 18 radical 6. Now hopefully you've noticed that what I have here is some like radicals. I combined that 6 and 3 to get the 18. We've got some like radicals. We've got 3 radical 3's here, and then we also have radical 6's here. So what that means is we can add the 7 and the 4 and add the negative 4 and the 18. So I'm just going to rewrite this one more time so you can see what I'm talking about. 7 radical 3 and 4 radical 3. And then a negative 4 radical 6 and an 18 radical 6. So we can combine these two, and we can combine these two. And when we do that, we're going to get, for our final answer, 7 plus 4 is 11. So 11 radical 3. And then negative 4 and positive 18 makes 14, plus 14 radical 6. And now we have simplified this a great deal. We only have 2 parts. They each have their own radical, and we can't simplify anymore. So what we did was we created like radicals right here, and then we combined like terms. So remember, the key here is simplifying each part of the original expression, because it often will create like radicals that you can add together. Now, before we finish, it's time for you to try some of your own. So try these 3. Good luck with them, and I'll see you at our next class.